Alright, this is the second video in partial fraction decomposition, section 3.4. So we're going to be looking at partial fraction decomposition, and we're going to be integrating something of the form p of x over q of x. And so the strategy is, if the degree of the numerator is greater than or equal to the degree of the denominator, then what you want to do first is perform long division, and that's going to make the integration a lot easier. Factor the denominator q of x into the product of irreducible factors. These will be of the form ax plus b to the n, or ax squared plus bx plus c to the m power. Irreducible quadratic factors do not have any real roots, so our irreducibles will be linear or quadratic. For each linear factor of the form ax plus b to the nth power, the partial fraction decomposition will have the form a1 over ax plus b plus a2 over ax plus b squared plus blah 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 plus a sub n over ax plus b to the n. For each quadratic factor of form ax squared plus bx plus c to the nth power, the partial fraction decomposition will have the following form: b1x plus c1 all over ax squared plus bx plus c plus b2 of x plus c2 ax squared plus bx plus c squared, all the way out to bxm plus cm all over ax squared plus bx plus c to the m power. And then this should have been an uppercase C right here. And so notice that your coefficients here on step 3, your factors here, the x is to the first power before the exponent is applied. So you can think of those are all your linear factors. And so notice that the degree of the numerator is 0. They are constants. Okay. Then when we get to the quadratic factors, the numerators are linears. Okay, so they're 1 degree less, and so that's going to be kind of the pattern here, doing the decomposition. So let's do some examples. So example number 1, we have 3x squared minus 8 all over x cubed plus 4x squared plus 4x plus 16 dx. So the degree of the numerator is 2, and the degree of the denominator is 3, so we're not going to do long division here. We are going to factor the denominator here, so we're going to factor by grouping. So x cubed plus 4x squared plus 4x plus 16. Greatest common factor is an x squared out of the first two terms, and then a 4 out of the second two terms. Okay, and so that'll factor into the linear x plus 4, and then the irreducible quadratic x squared plus 4. The roots of x squared plus 4 are plus and minus 2i, so they don't have any real roots. Okay, and so now we're going to perform our partial fraction decomposition. So 3x squared minus 8 all over x plus 4, x squared plus 4. We're going to write that as a over x plus 4 plus b x plus c all over x squared plus 4. Okay, all right. And so we'd have more terms, let's say that you had a square on the x plus 4. So then we'd have we'd have to use, I guess, letter D all over x plus 4 squared. Yeah, and if we had a cube, then we'd have plus ex plus f all over x squared plus 4 to the second power plus a gx plus h all over x squared plus 4 to the third power. And so we don't really do a whole lot like this because the systems of equations kind of get a little messy. So let's go ahead and take all of this off, and we'll go perform our partial fraction decomposition on what we got going on here. Okay, so I'll take all of that stuff off. Okay. All right, so we're going to clear the fraction and multiply by x plus 4 and x squared plus 4. And so this is going to give us 3x squared minus 8 is equal to a times x squared plus 4 plus bx plus c times x squared plus 4, or sorry, x plus 4, excuse me. So it's going to give us ax squared plus 4a plus bx squared plus 4bx plus cx plus 4c. Okay, and now we're going to match. So the coefficients on the x squared should be equal. So 3x squared, so just the 3, and the 3x squared should be equal to the ax squared plus bx. So just set the coefficients together, equal to each other. So 3 is equal to a plus b. Now we'll do the linears. So 4bx and cx. There's no linear on the left-hand side, so it's 0. So we have 0 is equal to 4b plus c. And then finally, we'll do the constant. Negative 8 is equal to 4c. Okay. Oh, sorry. I forgot somebody, didn't I? Negative 8 is equal to 4a plus 4c. There we go. I forgot somebody. Okay. All right. So the first equation here, I think what we're going to do is maybe solve for a and b in terms of c. I think that's what we're going to do. Let's find out. All right, so we solve for a. So we have a is equal to 3 minus b. No, we're going to get everything in terms of b. That's what we're going to do. Yeah, okay. Then we're going to solve the second equation in terms of c. So c is equal to negative 4b. And then we're going to go ahead and take the third equation, which has a and c in it, and we're going to replace those with their corresponding b's. Whoops. What did I hit? I hit the wrong button, didn't I? Okay, there we are. All right, so let's go ahead and make those substitutions. So negative 8 is equal to 4, and a was 3 minus b, plus 4c, and c was negative 4b. All right, so we have negative 8 is equal to 12 minus 4b minus 16b. So negative 20 is equal to negative 20b. So this tells us that b is equal to 1. So if b is equal to 1, then a is equal to 3 minus b. So a is equal to 3 minus 1, which is 2. And then c is equal to negative 4b. So c will be equal to negative 4. So our integral becomes 2 over x plus 4, x minus 4 over x squared plus 4. And then we're going to integrate with that with respect to x. All right, so the first part, the 2 over x plus 4, is going to be 2 ln absolute value of x plus 4, plus, and then we're going to split up the x minus 4 to be x over x squared plus 4, and then minus 4 over dx over x squared plus 4. So 2 ln absolute value of x plus 4. We'll need to do u substitution. So if we do a u substitution, u would be equal to x squared plus 4. du would be equal to 2x dx. So what we would need to do is multiply by 1/2 and by 2, and that offset each other, and then you would have the integral of du over u, which is going to be ln absolute value. So we go ahead and do that. Okay, so 1/2 ln absolute value of x squared plus 4, okay, minus 4, and then it's arctangent, integral of dx over x squared plus 4, so it's going to be 1 over a is 2, so 4 over 2, arctangent of x over 2, and then plus constant integration. We can go ahead and reduce the 4 over 2 to 2. And then the absolute value of x plus 4, we don't need the absolute value bars on there. It's not going to hurt it if you leave it, but it's not required because x squared plus 4 is always positive. Okay. All right, I think we got one or two more examples, so let's go ahead and look at the next one we got going on here. So we got the integral of 6x cubed plus 3x squared plus 2x minus 3, all over x squared minus 1, dx. Notice that it's a degree 3 over a degree 2, so we're going to want to perform long division. X squared minus 1 is your divisor. 6x cubed plus 3x squared plus 2x minus 3 is your dividend. Okay, x squared times 6x is 6x cubed. Negative 1 times 6x is negative 6x. Long division, we're going to subtract. 6x cubed minus 6x cubed is gone. Bring down the 3x squared. Okay, and then 2x minus negative 6x is going to be 2x plus 8x, which 2x plus 6x, which is 8x. And then we'll bring down the next term, the negative 3. X squared times 3 is 3x squared. And negative 1 times 3 is negative 3. I'm going to subtract. 3x squared minus 3x squared is gone. Bring down the 8x. And then negative 3 minus negative 3 will be negative 3 plus 3, so that's going to cancel out. And so our remainder is 8x, and our quotient is 6x plus 3. So our integral becomes the quotient, 6x plus 3, plus your remainder over your divisor. Okay, so that is going to give us 6x squared over 2 plus 3x. Okay, and then we'll go ahead and integrate 8 over x, we'll integrate 8 times the integral of x over x squared minus 1 dx. We'll do a u substitution. U is equal to x squared minus 1. Du is equal to 2x dx. So go ahead and steal a factor of 2 from the 8 and make that a 4. Okay, so that's going to be 4 integral of du over u. So 4 ln absolute value of u plus c. So 4 ln absolute value of x squared minus 1 plus c. And we'll need to leave those absolute value bars on there because we're not sure where the x is, so we want to make sure it's positive. All right, so this becomes 3x squared plus 3x plus 4 natural log absolute value of x squared minus 1 and plus your constant of integration. Okay, all right. We'll go ahead and look at one more. Okay, so we got one more to look at here. Example number 3. So we're going to look at the integral of x squared plus 47 over x cubed plus 3x squared and then dx. Okay, so x squared plus 47, the denominator factors to x squared times x plus 3. All right, so we got a over x plus 3 plus bx plus c all over x squared. You could also do b over x plus c over x squared. That would also work if you want to treat the x as a linear factor. That would also work out. Okay, we're going to multiply by the common denominator, x squared times x plus 3. So we have x squared plus 47 is equal to a times x squared plus bx plus c times x plus 3. We have ax squared plus bx squared plus 3bx plus cx plus 3. And just like, not the last example, but the example before that, we're going to set our quadratic coefficients equal to each other. So 1 equals a plus b. And then our linear, there's no linear on the left-hand side, so 0 is equal to b plus 3b plus c. And the constant, 47, is equal to 3c. So solving the last equation gives us 47 over 3 is equal to c. Substitute that into the second equation for c, and we'll solve that. So negative 47 over 3 is equal to 3b. Divide by 3, and so negative 47 over 9 is equal to b. And then substitute into the top equation, a plus negative 47 over 9 is going to be 56 over 9 when we add 47 over 9 to both sides. 1 is 9 over 9, so 9 plus 47 is 56. So 56 over 9 is equal to a. All right, so our integral is going to be 1/9 56 over x plus 3 minus 47x plus 141 over x squared dx. Okay, and if you distribute that 1/9 through, it is equivalent. You can verify that. So let's go on to the next slide here just to finish that up, since we don't have a whole lot of real estate left on this slide. So the integral of x squared plus 47 divided by x cubed plus 3x squared dx is going to be equal to 1/9 the integral of 56 over x plus 3 minus 47x plus 141 all over x squared dx. So we can integrate the first thing there, the 56 over x plus 3, that integrates to 56 ln absolute value of x plus 3. Plus, we're going to go ahead and split that up into two integrals, so and reduce. So, actually, we're not going to split up into two integrals. We'll just split up into two terms. So, negative 47x over x squared will reduce to negative 47 over x, and then we'll have 141 over x squared dx. So, 1/9, 56 ln absolute value of x plus 3 minus 47 ln absolute value of x minus 141 over x, and then plus constant integration. Okay. Alrighty, so there's a few examples of the partial fraction decomposition. Sometimes the algebra is going to get a little bit messy when you're trying to figure out what the decomposition is. Try to stay organized and write everything down. It'll make it a little bit easier in the event that you do make a mistake. You can go and troubleshoot and find where your error was. If you try to do too many steps in your head, then oftentimes you make a little mistake, and then everything is wrong from there on out. So try to be careful. Alrighty, well, that's it for partial fraction decomposition. We'll see you next time.